Hey everybody, and welcome back to our lesson on plane geometry. This is lesson 8, and we're looking at just finishing off this question 4 from last time, and then we're going to be moving on to polygons. So looking at this question here, where we're asked to prove that OAPB is a rhombus. So I said OA can equal OB and PA equal to PB because of equal radii in a circle. The radii in a circle in equal circles are equal. And then basically what I can say is here, therefore OA equals OB, which equals PA, which equals PB, because of the equal radii of a circle, and therefore all four sides equal. And OAPB is a rhombus. Cool, so that's part A done. Part B then asks you to show that AP is the perpendicular bisector of OP. So what you had to do there is write down, first of all, a property of a rhombus is that the diagonals are in fact perpendicular bisectors. So it's really important you know your properties of quadrilaterals. Then you can say, since OAPB is a rhombus, AB is the perpendicular bisector of OP from diagonals AB and OP. Okay, so what does all that mean? Well, what we know is that if you have a rhombus, so if you have a rhombus, basically you already know there's perpendicular bisectors in there, so that's pretty much why we could say what we did for part B earlier on. So make sure you write down your summary points for that lesson. Any questions you have a go at the exercises and write down any questions you have. The next section of work we're looking at is polygons. Now, polygons is a pretty cool section. We've learnt a lot about this before in kind of years 9 onwards. And the goals of the lesson from this section is to make sure you know how to apply the angle sum of polygons and how to apply this knowledge to problems. Okay, so the first thing you need to know is what a polygon is. Okay, so a polygon is a plane figure, closed plane figure with straight sides, and a regular polygon has all its sides and all its interior angles equal. So for example, in these ones here, these are all some polygons. Now this one should be joined here, that's just gone funny in the printing, so make sure you know that's a square, it's a closed shape. Also we know that we've got a pattern. Okay, so if you look at this, we've got a triangle with 3 sides, the number of triangles is 1, and the angle sum. Okay, and you could fill out this whole table and it would basically give us the rule for angle sum of a polygon, because what happens is you've got n here, take away the 2, okay, number of sides take away 2, and you're multiplying by 180, and that's actually the angle sum rule. Okay, so it's really important that you know that. The proof is that if you draw any n-sided polygon, then the sum of the exterior and interior angles is the number of sides times 180. And when you work through that algebra, you get 360 degrees. So that's for the fact that any amount of angles on the outside equals 360. So that's another important rule that you need to know there. Okay, so make sure you know that. Cool. The next section's asking you to do some things. So let's have a look at these questions together. It says find the interior angle sum and the size of each interior angle. Okay, there's not a lot of room here, so you might want to do this in your book. I'll try and squish it in. So in the first one, you'll notice that there is 5 sides. It's a pentagon. Okay, and in this pentagon, we want to find the interior angle sum. So we're going to go S equals 180 lots of number of sides, 5 minus 2. So in other words, times 3. And when I work that out, I'm going to get 540. If I then want to work out each angle, I would do that answer divided by the number of sides, which in this case is 5, and that gives me with 108 degrees. Okay, so this is the sum of all the angles inside the pentagon, and this is just the size of one of those angles. Okay, so that's the difference between the two. Okay, so for B, again, interior angle sum is 180 times the number of sides. And this looks like an octagon here. 1, 2, 3, 4, 5, 6, 7, 8. Yep, so 8 minus 2 in there. And when I work that out, my answer is 1080. And the size of each angle is 1080 divided by 8. And that gives me 135 degrees. Okay, for part C, you're doing a very similar thing. This is a septagon, so angle sum 180 times 5 essentially, which is going to be 900. For each angle, we'll do that answer and divide by 7, and that would give me 128.6 degrees. Okay, so it's really important you know what the question's asking you for and how to get the answer. For part D, the angle sum, a nonagon's 9 sides, so it would be 180, 9 minus 2. Dodecagon would be 180, 12 minus 2. Okay, and the answers to those when you type them in, you have 1260 for this one, and then for each you'd be doing 1260 divided by 9, which is 140 degrees, excuse me. Then for the dodecadon, we'd be doing 1800 divided by, so let me just write that down, 1800 divided by 12, which is 150 degrees. Okay, so in that question we're doing two things, working out the interior angle sum, and then we were also doing the size of each single angle. Okay, so this question's very similar, but it involves some algebra. So what we're going to do in this one is remember that this is an octagon. So the interior angle sum of an octagon with 8 sides was 1080. So you'd show the same working as you did above from question B. Then to get each angle, we did 1080 divided by 8. And that was 135 degrees. And that's the size of each angle. So in this one, we can say that 90 degrees must be 135. solve for t by dividing both sides by 9, and that tells me that therefore t is equal to 15 degrees. Okay, and that's your final answer. Nice. Okay, next one. How many sides would a regular polygon have if the exterior angle was 20? So on this one, what it's saying is you've got some kind of polygon and the outside angle in here is 20. Okay, which means the inside angle would have to be 160. And basically you're going to work backwards. So you've got 180, so you've got the angle sum over n being 160, because that's the size of each one, each interior one. And we want to work out the number of sides. Okay, so we're going to have 180 brackets n minus 2 is 160n. Solving for that equation, you've got 180n minus 360 is 160n. Take the 160 over and the 360 across, so you get 360 is 20n. Divide both sides by 20 and you get n is 18, so therefore it's an 18-sided polygon. Awesome. So for question B, it's kind of an explain why question, and it says explain why a regular polygon cannot have an interior angle of 100. Well, if you think about it like this, so I'll just do this one over here. If I have an interior angle of 100 degrees, it's not possible because the exterior angle would need to be acute. Okay? And that can't really happen here. Okay, that can't really happen. Because if that's 100 and you need an 80-degree angle here, you need an 80-degree angle on this outside. It's not possible. Because if you think about it, if that was 90, the other would need to be 90. But this is more than 90, so they're saying this would have to be less than that. And that doesn't make sense. Fantastic. So this next bit here, the question's saying, what's the exterior angle of a regular polygon with 15 sides? So step 1, find the angle sum. So you're going to go 180 lots of 13, which is 2,340. If I want to get the outside one, so picture it like this, okay? If I want to get this outside one here, I need to work out the inside one. So each inside one is 2,340 divided by 15. And that's going to be equal to 156. So this is 156 in here. And that's actually the answer to part B. So we've done B first, which is cool. So I want to get x. So x is going to be equal to 180 minus 156. And that's going to give me 24 degrees. And my reason for that is adjacent supplementary angles. Cool. So the last question asks you to basically write the rule out for that. Okay, so don't worry about question C. But for part A, what would be the exterior angle of a polygon with n sides? So to get the exterior angle, you would have to do 180, take away how you work out for the inside. And to get the interior angle, you would have to do just the bit over there. So the interior angle, you would have to do 180 n minus 2 over n. Okay, write your summary. I'll write down any questions you have a go at the exercise, and that's the end of this